Imagine a world where humans could travel beneath the waves, exploring the mysteries hidden below the ocean's surface. This dream has fascinated inventors for centuries, leading to the creation of submarines, machines that allow us to dive deep, stay underwater for months, and even change the course of history. Today we embark on a cinematic journey to discover how submarines were invented, evolved, and revolutionized warfare, science, and exploration. From early sketches to nuclear-powered giants, let's unravel the secrets of underwater travel and the engineering marvels that made it possible. Long before submarines existed, ancient civilizations imagined underwater travel. Stories from Greece and Rome described diving bells and mythical machines. These early concepts inspired inventors to think about how humans could survive and move underwater. The idea was simple: create a vessel that could keep people safe from water pressure and allow them to breathe. While these ancient dreams were far from reality, they laid the foundation for future innovation. The fascination with the unknown depths sparked curiosity and set the stage for centuries of experimentation. First real attempts to build submarines began in the 17th century. One of the earliest was Cornelius Drebel's vessel, which used oars and leather to move underwater in the Thames River. Drebel's submarine was primitive, but it proved that humans could survive below the surface for short periods. Other inventors soon followed, experimenting with different shapes, materials, and propulsion methods. These early submarines were dangerous and unreliable, but they marked the beginning of a new era in marine engineering. The quest for underwater travel was no longer just a dream, it was becoming reality. One of the biggest challenges in submarine design was controlling buoyancy. Early inventors realized that to dive and surface, submarines needed a way to adjust their weight. Ballast systems were developed using tanks that could be filled with water or air. By changing the amount of water in these tanks, submarines could sink or rise. This innovation was crucial, allowing submarines to operate safely and efficiently. Ballast systems are still used today, forming the backbone of modern submarine technology and enabling precise control underwater. Buoyancy control is what lets submarines dive and float. When a submarine wants to dive, it fills its ballast tanks with water, making it heavier and causing it to sink. To surface, it pumps air into the tanks, pushing the water out and making the vessel lighter. This simple but ingenious system is at the heart of every submarine. It's a delicate balance: too much water and the submarine sinks, too fast, too little and it can't dive. Engineers have refined this process over decades, making modern submarines incredibly precise in their movements. Underwater, pressure increases rapidly with depth. Early submarines struggled to withstand this force, often leaking or collapsing. Engineers developed strong hulls made from steel and other materials, shaped to distribute pressure evenly. Modern submarines use advanced alloys and precise construction techniques to survive extreme depths. Pressure management is critical not just for the safety of the crew, but for the integrity of the vessel. Without it, submarines would be crushed by the weight of the water above. This challenge pushed engineering to new heights and remains a key focus in submarine design. Moving underwater is no easy task. Early submarines relied on human power, oars, pedals, and hand cranks. As technology advanced, inventors experimented with steam engines, electric motors, and eventually diesel engines. Each new propulsion system brought greater speed, range, and reliability. Today's submarines use nuclear reactors, providing nearly unlimited power and allowing them to stay submerged for months. Propulsion systems are the heart of submarine mobility, transforming these vessels from slow, dangerous experiments into fast, stealthy machines capable of crossing oceans. Breathing underwater is a major challenge. Early submarines carried limited air, forcing crews to surface often. Engineers developed systems to scrub carbon dioxide and generate oxygen, allowing submarines to stay underwater longer. Modern nuclear submarines use advanced life support systems, recycling air and water to keep crews alive for months. Oxygen supply technology is essential for deep-sea missions, military patrols, and scientific exploration. Without it, submarines would be limited to short dives, unable to unlock the mysteries of the ocean. Seeing underwater is nearly impossible, so submarines rely on sonar, sound navigation, and ranging. Sonar systems send out sound waves and listen for echoes, helping submarines detect obstacles, enemy ships, and underwater features. This technology revolutionized submarine warfare, making it possible to hunt and evade targets in complete darkness. Modern sonar systems are incredibly advanced, capable of mapping the ocean floor and tracking objects miles away. Sonar is the submarine's eyes and ears, essential for navigation, safety, and combat. Navigating underwater is a unique challenge. Submarines use gyroscopes, inertial navigation, and GPS when near the surface. Deep below, they rely on sonar and dead reckoning to estimate their position. Modern submarines are equipped with sophisticated computers and sensors, allowing precise navigation even in the darkest depths. These systems are vital for military missions, scientific research, and safe travel. Navigation technology continues to evolve, making submarines more accurate and reliable than ever before. Periscopes are iconic submarine tools, allowing crews to see above the water while staying hidden below. Early periscopes were simple tubes with mirrors, but modern versions use advanced optics and cameras. Periscopes are essential for navigation, surveillance, and communication. They let submarines observe ships, coastlines, and threats without surfacing. Today, some submarines use electronic periscopes, transmitting images to screens inside the vessel. This technology keeps submarines stealthy and safe, blending old ideas with new innovation. Diesel-electric engines transformed submarines in the early 20th century. These systems use diesel engines to charge batteries, which power electric motors underwater. This innovation allowed submarines to travel farther and stay submerged longer, making them formidable weapons in World War I and II. diesel-electric technology is still used in many modern submarines, offering a balance of power, efficiency, and stealth. The combination of diesel and electric propulsion marked a turning point in submarine history, paving the way for nuclear-powered giants. Nuclear submarines are the pinnacle of underwater engineering. Powered by nuclear reactors, they can stay submerged for months, travel thousands of miles, and operate in extreme conditions. These vessels are used for military patrols, scientific missions, and exploration. Nuclear technology provides unmatched endurance and power, making submarines faster, quieter, and more capable than ever before. The development of nuclear submarines changed the balance of naval power and opened new frontiers in underwater travel. Diving is a complex process. Submarines fill their ballast tanks with water, increasing their weight and sinking below the surface. The crew carefully monitors depth and pressure, adjusting ballast and trim to maintain stability. Modern submarines use automated systems to control diving, making the process safer and more precise. Diving allows submarines to hide from enemies, explore the ocean, and conduct research. It's a delicate balance of engineering, physics, and skill, perfected over decades of innovation. The surface, submarines pump air into their ballast tanks, forcing water out and making the vessel lighter. This process is carefully controlled to avoid sudden movements or instability. Surfacing is essential for communication, resupply, and crew safety. Modern submarines can surface quickly in emergencies, using advanced systems to manage buoyancy and pressure. The ability to float and surface safely is a testament to the ingenuity of submarine engineers, blending science and technology to master the ocean. Balancing pressure is vital for submarine safety. The hull must withstand the crushing force of deep water, while keeping the interior comfortable for the crew. Engineers use strong materials and precise construction to distribute pressure evenly. Modern submarines have sensors and computers to monitor hull integrity, alerting crews to any danger. Pressure balance is a constant concern, shaping every aspect of submarine design and operation. It's a challenge that pushes the limits of engineering and science. Nuclear submarines can remain underwater for months, thanks to their powerful reactors and advanced life support systems. Crews recycle air and water, manage food supplies, and maintain strict routines. Staying submerged for long periods is essential for military patrols and scientific missions. It requires careful planning, discipline, and technology. The ability to live underwater for months is a remarkable achievement, opening new possibilities for exploration and defense. Marines use sonar and other sensors to detect enemy ships and threats. Sonar sends out sound waves, listening for echoes that reveal the location and movement of targets. Modern submarines have passive and active sonar, radar, and electronic surveillance systems. These tools are essential for military operations, allowing submarines to hunt, evade, and protect themselves. Detection technology is constantly evolving, making submarines more stealthy and effective in combat. Communicating underwater is a major challenge. Radio waves don't travel well through water, so submarines use special systems like VLF, very low-frequency radio acoustic signals, and satellite links when near the surface. Deep below, communication is limited, requiring careful planning and coordination. Modern submarines use encrypted messages and advanced technology to stay connected with command centers. Communication is vital for safety, mission success, and coordination with other vessels. Military submarines are designed for stealth, power, and endurance. They carry torpedoes, missiles, and special forces, operating in secret to protect nations and deter threats. These vessels are equipped with advanced sensors, weapons, and navigation systems. Military submarines play a crucial role in naval strategy, surveillance, and defense. Their ability to operate undetected makes them powerful tools in modern warfare, shaping the balance of power around the world. Research submarines are built for exploration and discovery. They carry scientists, cameras, and sensors to study the ocean, marine life, and geology. These vessels can dive to extreme depths, collecting data and samples for scientific research. Research submarines have revealed new species, mapped the ocean floor, and uncovered ancient shipwrecks. Their work is essential for understanding the planet, protecting ecosystems, and advancing technology. Rescue submarines are designed to save lives in emergencies. They can reach stranded crews, deliver supplies, and evacuate people from damaged vessels. Rescue subs are equipped with special tools, medical equipment, and communication systems. Their missions are dangerous and demanding, requiring skill, courage, and advanced technology. Rescue submarines play a vital role in maritime safety, responding to disasters and protecting lives at sea. Autonomous underwater drones are the latest innovation in marine technology. These unmanned vessels can explore, map, and monitor the ocean without human crews. Drones use AI, sensors, and advanced propulsion to operate independently, collecting data and performing tasks. They are used for research, surveillance, and environmental monitoring. Autonomous drones are changing the way we study and protect the ocean, offering new possibilities for exploration and discovery. Submarines and drones are essential for deep-sea exploration. They allow scientists to reach the ocean's most remote and mysterious places, studying life, geology, and chemistry. Deep-sea missions have discovered new species, hydrothermal vents, and ancient shipwrecks. Exploration technology is constantly evolving, making it possible to dive deeper and stay longer. The quest to understand the ocean drives innovation and reveals the hidden wonders of our planet. Submarines play a role in laying and maintaining underwater internet cables. These cables connect continents, enabling global communication and commerce. Submarine crews and drones inspect, repair, and protect these vital links. The process is complex, requiring precise navigation, engineering, and teamwork. Underwater cables are the backbone of the modern internet, making submarine technology essential for global connectivity. Submarines are used for surveillance and security, monitoring shipping lanes, borders, and underwater infrastructure. They carry sensors, cameras, and communication systems to detect threats and protect assets. Surveillance missions are vital for national security, environmental protection, and maritime safety. Submarine technology is constantly evolving, making these vessels more effective and stealthy in their operation. Submarines have revolutionized scientific discovery, allowing researchers to study the ocean in ways never before possible. They collect data on marine life, geology, chemistry, and climate. Submarine missions have revealed new ecosystems, solved mysteries, and advanced our understanding of the planet. Scientific discovery drives innovation, inspiring new technologies and expanding the boundaries of knowledge. Submarine history is filled with famous inventions and breakthroughs. From Drebel's first vessel to the USS Nautilus, each milestone pushed technology forward. The development of sonar, nuclear power, and autonomous drones changed the way submarines operate. These inventions are the result of curiosity, experimentation, and determination. They shaped the course of history and opened new frontiers in underwater travel. Inventors like Cornelius Drebbel, David Bushnell, and John Holland were pioneers in submarine technology. Their experiments and innovations laid the groundwork for modern vessels. These pioneers faced danger, skepticism, and technical challenges, but their determination changed the world. Their stories inspire new generations of engineers and explorers, reminding us that curiosity and courage drive progress. World War I and II saw a technological race in submarine development. Nations competed to build faster, stealthier, and more powerful vessels. Innovations like diesel-electric engines, sonar, and torpedoes changed naval warfare. Submarines became key players in battles, blockades, and intelligence missions. The race for submarine supremacy shaped military strategy and drove rapid advances in engineering. Cold War brought new challenges and innovations in submarine technology. Nuclear-powered vessels, ballistic missile submarines, and advanced sonar systems were developed. Submarines played a crucial role in intelligence, deterrence, and strategic balance. The Cold War era pushed engineering to new heights, creating some of the most advanced machines ever built. These innovations continue to influence submarine design and operation today. Submarines and ships are both essential for maritime operations, but they serve different purposes. Ships travel on the surface, carrying cargo, passengers, and supplies. Submarines operate below, offering stealth, endurance, and unique capabilities. The engineering challenges are vastly different. Submarines must withstand pressure, manage buoyancy, and operate in darkness. Comparing submarines and ships highlights the complexity and innovation required for underwater travel. Underwater drones are changing the way we explore and monitor the ocean. Unlike submarines, drones are unmanned, smaller, and often more agile. They can operate independently, collecting data and performing tasks without human crews. Submarines offer endurance, power, and crewed missions, while drones provide flexibility and cost-effectiveness. The combination of both technologies is shaping the future of marine exploration and engineering. Underwater engineering is one of the most difficult challenges in human history. Submarines must withstand immense pressure, manage buoyancy, and operate in complete darkness. Every system from propulsion to life support must be reliable and safe. Engineers face constant obstacles from material fatigue to navigation errors. The complexity of underwater travel drives innovation, pushing science and technology to new limits. The future of submarines is driven by artificial intelligence. AI-powered vessels can navigate, detect threats, and manage systems autonomously. These submarines use sensors, computers, and machine learning to operate safely and efficiently. AI technology is transforming marine engineering, making submarines smarter, quieter, and more capable. The possibilities are endless, from autonomous fleets to deep ocean habitats. Silent propulsion is a key focus in submarine design. Engineers are developing new systems that reduce noise, making submarines harder to detect. Technologies like electric motors, advanced propellers, and magnetic drives are being tested. Silent propulsion improves stealth, safety, and efficiency, shaping the next generation of underwater vessels. The quest for silence is driving innovation and changing the way submarines operate. Future submarines may support deep ocean habitats, allowing humans to live and work underwater for extended periods. These habitats would use advanced life support, energy, and communication systems. Engineers are exploring ways to build safe, comfortable environments below the surface. Deep ocean habitats could revolutionize exploration, research, and even tourism, opening new frontiers in marine science. Autonomous underwater fleets are the next step in marine technology. These groups of drones and submarines can work together, exploring, monitoring, and protecting the ocean. Fleets use AI, sensors, and communication systems to coordinate missions. Autonomous fleets offer new possibilities for research, defense, and environmental protection, making underwater operations more efficient and effective. Engineers are imagining new forms of underwater transportation. High-speed submarines, passenger vessels, and cargo subs could connect cities and continents below the waves. Futuristic designs use advanced propulsion materials and navigation systems. Underwater transportation could revolutionize travel, commerce, and exploration, making the ocean a new frontier for human activity. Evolution of submarines spans centuries, from ancient concepts to modern marvels. Early experiments paved the way for breakthroughs in ballast, propulsion, and pressure management. World wars and the Cold War drove rapid innovation, leading to nuclear-powered giants and autonomous drones. Today, submarines are essential for defense, science, and exploration. The timeline of submarine evolution is a story of curiosity, courage, and engineering brilliance. Submarines like the USS Nautilus, Alvin, and modern nuclear vessels have achieved remarkable feats. Alvin explored the Titanic wreck while nuclear subs patrol oceans for months. Autonomous drones monitor coral reefs and lay internet cables. These real-world examples showcase the versatility and power of submarine technology, blending science, engineering, and adventure. Pairing submarines with ships and drones highlights their unique strengths and challenges. Submarines offer stealth and endurance, ships provide cargo and passenger transport, and drones deliver agility and cost-effectiveness. Each technology serves a different purpose, but together they advance marine exploration and engineering. Understanding these differences helps us appreciate the complexity and innovation behind underwater travel. Submarines are engineering marvels combining physics, materials, science, and technology. Every system from propulsion to life support is designed for reliability and safety. The challenges of underwater travel drive innovation, inspiring new solutions and breakthroughs. Submarine engineering is a testament to human ingenuity, pushing the boundaries of what's possible beneath the waves. Invention and evolution of submarines are driven by curiosity and discovery. Inventors, engineers, and explorers push the limits of science to unlock the mysteries of the ocean. Submarines reveal hidden worlds, inspire new technologies, and expand our understanding of the planet. Curiosity fuels progress, making underwater travel one of humanity's greatest achievements. Submarines have changed the world, transforming warfare, science, and exploration. From ancient dreams to futuristic AI-powered fleets, the journey is far from over. Engineers and explorers continue to innovate, imagining new ways to travel, live, and work underwater. The ocean remains a frontier of discovery, challenge, and opportunity. As we look to the future, submarines will lead the way, revealing the secrets of the deep and inspiring generations to come.